Good evening students. Next we are going to discuss about non-restoring division. So start it over again here. Next we are initializing same as like your restoring, but here we are going to check it over the condition of A, whether A is less than 0. Then we are going to go over for shift left A and Q and making over the accumulator value with addition of M. And here shift left of AQ, if it is going to be greater than 0, A is equal to A minus M. So next again with this condition we have to check it out whether A is less than 0. If it is yes, then you will be going over to this process. If it is going to be no, then we are coming over to the Q naught position as 1. And next we are making over the count value is equal to count minus 1. If count is equal to 0, then you will be going over for the next process. If not, then again it will be rotating over this process till the count becomes 0. So when count becomes 0, what happen? You will be coming out here for checking whether again the accumulator is having a positive number or a negative number. If it is going to be having over a negative number, then you will be adding over the accumulator with plus M. If it is not, then you will be going over for the end condition. Okay. So now we'll have the same problem which we have discussed for restoring. How we are going to perform over in your non-restoring. So in non-restoring, what you are going to do is the given value is 8 and divided by 4. So 8 is represented over in your binary value as 1000 and 4 is represented in again a binary value as 0100. So Q is going to be your dividend and M is going to be your divisor. To find it out your minus M, what you are going to do? You are going to find it out the 2's complement of M. So first you are finding out the 1's complement, then plus 1. So you are finding out the 2's complement of it. Okay. So now whenever you are having minus M, we have to substitute this value. Whenever you are having plus M, we have to substitute this value. Got it? Okay. Now we'll start over our operations. So initially A value will be taken over as 4 zeros and Q will be taken over as 1000. And the count value will be made over as 4. So the first operation is we have to check it out whether A is less than 0. So here A value is initially 0. So it is going to be A is less than 0, false. Okay. So we are coming over shift left of A and Q and then performing over A is equal to A minus M. So we are performing minus M, then we have to take it over your 2's complement of M and that you have to substitute over here. So again addition 1 plus 0 1, 0 plus 0 0, 0 plus 1 is 1. 0 plus 1 is 1. Now based upon this leftmost bit of A, if it is going to be 1, then your Q naught position will be assigned it over it as 0. If it is going to be 0, you are assigning over it as an 1. Okay. So next again we are going to decrement the count value. So count value is decremented. Again we are going over to the first step. So again you checking over whether the value of your A is going to be negative or positive based upon this. So here 1 it is there, so it is a negative value. So negative value means it is going to be an true condition of your A is less than 0. Then we are performing over shift left AQ and then we are adding over accumulator with your multiplicand. So 0 1 00. So add it over this value based upon this value of your output. So again we are finding out whether the Q naught position will be having 0 or 1 based upon this. Okay. So we are rounding over it. Whenever it is going to be 1, then your position of your Q naught will be 0. Okay. Again you are decrementing your count value. So count value becomes 2 here. Next part, again the count value will be moving over to it. Again we are finding out the shift left operation and shift left next we are going to have it over A equal to A plus M. So performing over addition and again based upon this value we are making over the Q naught position value as 1. So we are setting over Q naught is equal to 1 because here the leftmost bit of your A is going to be 0. Okay. So again the count value is being decremented here. Next shift left of A and Q. So shift left of A and Q, you are moving over all the zeros and then we are removing over the last box to be empty. Next you have to check it out whether we are going to have it over a minus m or a plus m based upon your previous condition. So if it is going to be 0, it is greater than 0. Okay, so we are making over 0 plus a minus m. So 1 1 0 0. So you are adding over all those values, and based upon the leftmost bit of a, we are setting over the q naught value. So if it is going to be 1, then we are making over the q naught value as 0. Okay, and then we are making over the count value as 0, because each and every time whenever we completed one cycle, we will be reducing over your count values. So when the count value becomes 0, what happen? We have to stop over our operation, and whatever stored over in the Q register, that is going to be your quotient. Okay, whereas what is the about the remainder part is, we have to check it out again at the last condition whether a is less than 0. If a is going to be greater than 0 or less than 0, it is based upon this output. So when you are coming over here, the a's leftmost bit is 1, so it is going to be an less than value of a. So whenever if it is going to be less than, then you have to perform a is equal to a plus m. So performing addition operation. So 0 plus 0 0, 0 plus 0 0, 1 plus 1 0 1. So 1 plus 1 0 1. So 1 is overflow condition, remove it over. So remaining thing is going to be the remainder part, and this is going to be your quotient part. So always the quotient will be stored over in your Q register, and the remainder will be stored over in your A register. Got it? So try it out with some other problems with this, and mail it over if any doubt is there. Okay, thank you.